Hello everyone. Today we're going to learn about Ohm's law. So Ohm's law is the equation you see here, V equals IR, where V represents the voltage, I represents the current, and R represents the resistance. Resistance is typically given in ohms, and if you're unfamiliar, this guy right here is a resistor, and a resistor is just a passive circuit element that restricts the flow of current. Now, current is given in amps, and voltage is typically given in volts. So, assuming that we have a constant voltage, and we increase the resistance, the current will decrease. Now, if we, again, constant voltage, decrease the resistance, the current will increase. So resistance and current are inversely related, which makes sense. As we apply more resistance and restrict the flow of current more, the current's going to decrease. And if we decrease the resistance and lessen the restriction on the current will increase. All right, so here we're being asked to derive how series resistors combine. So we've got a 10-volt voltage source in series with 3 resistors here. This looks like a great application for KVL, which states that the voltage drops through a loop in a circuit must sum to 0. So I'm going to write these voltages as VR1, VR2, and VR3. I'm going to label the positive and negative nodes of each resistor. And I know which one's positive and which one's negative because if current flows out of the positive terminal of the voltage source, current has to flow from higher potential to lower, right? So think of each resistor as like a hill. We've got our higher potential here and our lower potential here. And the current is like a boulder sitting at the top. It has to roll down. All right? So now, in regards to determining the signs here, I like to again follow the flow of current and see which signs we run into. So, following here, we run into R1 and we run into a positive sign. So VR1 is going to be positive. Then, if we keep going here, we run into the positive terminal of VR2. The VR2 is going to be positive. Keep going, run into VR3. And then if we go out of VR3, we keep going, and we run into the negative terminal of the voltage source, making it negative. And again, this is all equal to 10, or 0, sorry. So now we add 10 to both sides. We get 10 equals VR1 plus VR2 plus VR3. So here's where Ohm's law comes into play. So we know V equals IR, right? So there's only one main path for current to flow in this circuit, right? It's out of the positive terminal through R1, through R2, and through R3, right? So the current through all these elements is constant. So in series, current is the same, which is probably a better way to word it than constant. Okay? So we know I is the current flowing out of this voltage source and the current through each of these 3 resistors. So VR1 we can represent as I times R1. VR2 we can represent as I times R2. And VR3 we can represent as I times R3. So factor out an I, R1 plus R2 plus R3 equals 10 volts. If we divide both sides by I, we get 10 over I equals R1 plus R2 plus R3. Now, going back to Ohm's law, V equals IR, if we divide both sides by I and we get voltage over current, we notice that we get resistance. So this tells us that resistors in series add R1 plus R2 plus R3. Okay? Next example, parallel resistance, asks us to derive how parallel resistors combine. So this is a great application of KCL. So we've got a node here, which is shared between R1, R2, and R3, and we've got a node here. So again, Ohm's law, we know V equals IR. We know the voltage across these three is all 10, right? Because they share the same nodes as a 10-volt source. So we've got 10 equals I. Now I'm going to label the current down here is I1, current here is I2, and current here is I3. So 10 equals I1 R1, 10 equals I2 R2, and 10 equals I3 R3. Okay? Now I'm going to make a temporary variable here. R parallel equals the parallel combination of these. So that's TBD. But we can use Ohm's law and know that 10 equals IT, which is going to be I1 plus I2 plus I3. 10 equals IT times R parallel, right? Okay, so now we can substitute this in for IT. So we get 10 equals I1 plus I2 plus I3 times R parallel. And now going over here, we know that I1 equals 10 over R1. I2 equals 10 over R2. And I3 equals 10 over R3. So we can plug those in over here. We get 10 equals 10 over R3 plus 10 over R2 plus 10 over R1, all times R parallel. Now we can factor out a 10 here. We get 10 equals 10 R parallel of 1 over R3 plus 1 over R2 plus 1 over R1. 10's cancel. Divide both sides by R parallel. We get 1 over R parallel equals 1 over R3 plus 1 over R2 plus 1 over R1. Now flip this. We get R parallel equals 1 over R3 plus 1 over R2 plus 1 over R1. Okay? So that's how resistors combine in parallel. And with each successive resistor, you just add one more to the denominator. All right? Now, let's move into some actual examples here. So, circuit example 1. Find the current I supplied from the voltage source. So, again, we've got current flowing out of the positive node of this voltage source. Using KVL, I'm going to denote this is VR1, this is VR2. We know that 10 volts has to equal VR1 plus VR2, right? Similar to the first example we looked at today. And we know R1 is 10 ohms, and R2 is 100 ohms. So we can take I times 10 plus I times 100 equals 10. Factor out an I, get 110I equals 10. Therefore, I equals 10 over 110 amps. All right, that's that one. Now here's our last one. Find the current I supplied from the voltage source. So we're going to use KCL here. Let's call this node A. VA. We've got current coming in, which I'll make negative here. We've got current going down, and we've got current going to the right. So the current going down, again using Ohm's law, is VA over 20. So V equals IR, divide by R. Get I equals V over R. Same for this guy over here, VA over 20, which is this. So now all that's left is to represent this current, which we have going out. So we're going to take VA minus 10 over 10 ohms, which again, Ohm's law, we've got the voltage difference, which is VA minus 10 volts, over the resistance, 10 ohms, gives us the current. Now we've got VA minus 10 over 10 plus VA over 20 plus VA over 20 equals 0, because again, KCL states that all the current in and out of the node must sum to 0. So we can simplify this and get VA over 10 minus 1 plus VA over 10 equals 0. Add these two VAs, move 1 to the other side, and we get VA over 5 equals 1. Multiply both sides by 5, and we get a VA of 5. Okay? Now all we need to do is plug that in here, because this is the current here, and flip the sign, and we'll know the current supplied by the voltage source. So if we take 5 minus 10 over 10, which gives us negative 5 over 10 minus 1/2, flip the sign, so the current out of this voltage source here is plus 0.5 amp.